Ever wondered how our minds process the world around us? How we recognize a face in a crowd or predict outcomes based on patterns? The human brain, with its intricate network of neurons, accomplishes these tasks with ease. But could we replicate this process in a machine? Enter the domain of artificial neural networks, the brain-inspired system designed to replicate the way we humans learn. In essence, an artificial neural network, or AN, is a computational model based on the human brain structure. It comprises interconnected nodes or neurons that work in unison to solve complex problems. Picture this: each neuron in an AN receives a set of inputs and generates an output. The outputs from one layer of neurons then become the inputs for the next layer. This process continues until we reach the final layer, which provides the final output. The connections between these neurons have weights which dictate the influence each input wields on the output. Now, how do these networks learn? ANs are trained using large volumes of data. The weights of the connections between neurons are tweaked and adjusted until the AN can predict the output for new inputs accurately. Once trained, an AN can make predictions on new unseen data without any further training. ANs are versatile, finding use in a multitude of applications. They're employed in image recognition, identifying objects in images such as faces, cars, and animals. They're instrumental in natural language processing, enabling understanding and generation of human language. They even help in medical diagnosis, assisting doctors in identifying diseases and suggesting treatments. And in the financial sector, ANs are used to predict stock prices, interest rates, and other financial trends. To simplify the concept of how an AN works, imagine a group of people sitting in a circle. Each person holds a different piece of information: a number, a color, or a word. They pass their information to each other, updating their own based on what they receive from others. After a few rounds, everyone in the circle has all the information initially distributed among them. This is how a neuron network operates. The neurons pass their outputs to each other, each updating its output based on the other's outputs. Over time, the neurons learn to identify patterns in the data and make accurate predictions. In summary, artificial neural networks, inspired by our own brain's functioning, offer a powerful tool for machine learning. They're being used to solve a myriad of problems across diverse fields. By replicating the way we humans learn and process information, ANs are bringing us one step closer to truly intelligent machines.